Welcome back to this, another lesson for my Year 8 students on index laws, multiplying and dividing. Yes, another evening spent alone in a room talking to myself. What could I possibly ask for in life? Okay, so let's recap what we did before, because I think that's probably going to be quite important. Now remember, an index number is nothing more than a floaty number. And so if I have 2 with a floaty 2, this thing here, remember, is called an indice or an index. Okay, I think of it as a floaty number. Why? Because it's a number what is floating in it, Gov. Now, that in this situation means 2 times 2, which is 4. So for example, if I have 3 cubed, that's exactly the same as 3 times 3 times 3. Remember, that little floaty number effectively says take this big number here and write it this many times. So what is 3 times 3 times 3? Well, I know that 3 times 3 is 9. Copy down the times by 3. And I know that 9 times 3 is 27. And so there we go. 3 to the floaty 3 is 27. Let's think of something a little bit harder. What about 10 to the floaty 4? Well, that just means 10 times 10 times 10 times 10. And I'm pretty sure we can do most of that in our head. That will have 1 and 4 zeros. Did you notice anything? Interestingly, with the 10 and a floaty 4, this 4 here stands for how many zeros there are. Now, that doesn't work in all cases for all numbers, but it does for 10. So if I have 10 to the floaty 7, that's the same as 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, and let's have just one more, times 10. And in this case, that would be 10 and 2, 3, 4, 5, 6 zeros, or 10 million, right? And again, if you notice how many zeros I've got, yep, there are 7. But if I had 2 to the floaty 7, that would be 2 times 2 times 2 times 2 times 2 times 2 times 2. And that would give me 1, 2, 3. Well, I can't do that in my head. So 2 times 2 is 4, times by 2 is 8, times by 2 is 16, times by 2 is 32, times by 2 is 64, and times by 2 is 128. And there we go. So that's equal to 128. And here's my little smiley face because I'm feeling very happy. So floating numbers work with numbers, all right, really well. And we know what it is. But remember, an expression you need to learn or to know is that when you write it out like this in long form, it's called expanded notation, right? Or expanded form. That's the important word. The word expanded basically tells you write it long ways. If they want you to have the answer and actually give the total value, the chances are they will say something like evaluate, all right? And that just means find the number, all right? So that's it with numbers, but what about letters? Does it work that way too? Well, of course it does, because a floaty number, remember, tells you to write that base thing as many times as the floaty number has, and just put time signs between it. So let's go back. Let's say a squared. We know that is a multiplied by a. Yay! And we know that a to the floaty 3 means like a times a times a. And a to the floaty 4 is a times a times a times a. Now last lesson, or last video, we looked at the idea of, well, what is a squared times a to the floaty 3? Now what do you notice? We notice that this letter and this letter here are the same, and they are both separated by a times. Well, we can write this in expanded notation. So a squared is the same as a times a, so that's the a squared done. And then let's copy this times back in. And then a cubed is the same as a times a times a. But because we've got a whole load of a's, and a times a times a times a times a, I can write that as a to the floaty 5. So in shorthand, a squared times a cubed, and notice I call that a cube, the floaty 3 is generally called a cubed, is equal to a to the floaty 5. Oh, what about a to the floaty 2 times a to the floaty 4? Well, let's write it in expanded notation. That's a times a. There's my times, I'll copy it in. And a to the floaty 4 is 1, 2, 3, 4. Well, we've got a load of a's together, so a times a times a times a to a is a to the floaty 6. So a to the floaty 2 times a to the floaty 4 is a to the floaty 6. This is so cool. Now, last video we talked about, well, was there something we could notice? Well, so far let's write down a to the floaty 2 times a to the floaty 3, and we decided that was a to the floaty 5. A to the floaty 2 times a to the floaty 4 must be a to the floaty 6. And to continue the pattern, a to the floaty 2 times a to the floaty 5, I'm going to tell you is a to the floaty 7. How would I know that? Well, in my head, I could be turning around going, well, it must be because, you know, to go from here to here, I'm just adding another a, or I'm multiplying by another a. And so there must have been another a, and so hence the 7. But let's look more closely at the idea of the floaty numbers. What do we notice about 2 and 3 and 5? Is there a link? 2 and 4 and 6. Is there a link? 2 and 5 and 7. Is there a link? Well, of course there is. There's a fabulous link, because if I do 2 plus 3, I get 5. If I do 2 plus 4, I get 6. And if I get 2 plus 5, I get 7. So, ladies and gentlemen, we've just discovered a rule of floaty numbers. And here is the rule. When I multiply two floaty numbers together, then I can add the powers. Right? So when I multiply two floaty numbers together, I can add the powers. So if I have a squared times a to the 10, are they multiplied together? Yep. Do they have the same base? Now that's really important here. The letters or numbers have to be the same. So a to the floaty 2 times a to the floaty 10 is a to the floaty 12. What about a to the 12 times a to the 10? Well, remember, always ask yourself the question, are they connected by a times? Yes. And are the bases the same? Yes. So what do? Well, when I multiply two floaty numbers together, I just add the powers. So that becomes a to the 22. Fabulous smiley face. I am a genius. Or rather, you're going to be a genius pretty soon. Does this work with numbers? Absolutely. If I have 2 to the floaty 3 times 2 to the floaty 4, are they connected by a times? Yes. Are the big numbers the same? Yes. So there's my big number. And what do I do to the powers? Well, 3 plus 4 is 7. Genius, tick, smile, and the crowd goes crazy. This is interesting. Well, let's just go back to this one here. We said at the top that a squared is equal to a times a. So that must mean that a times a is equal to a with a floaty 2. But there are no powers here. There are no floaty numbers. Well, actually, yes, there are. Because remember, there is one number that you don't have to write generally. And what would that one number be? Well, I don't know. What would that one number be? Well, in this situation, absolutely. Generally, if there's not a number, it's a floaty 1. And let's just check. Does the rule work? Is there a times? Yes. Are the bases the same? Yes. So what do? I add the numbers together, and 1 plus 1 gives me 2. It works brilliantly. And again, look, 1, 2, 3, 1, 2, 3, 4 if I put my floaty numbers in. Just be very, very careful, because remember, this only works if the bases are the same. So if I was given an example of a squared times b to the 3, that would not become ab to the floaty 5. It's not possible, because are the bases the same? No. They are connected by a times, but this a and this b are not the same, and so any answer I would try and get would be stupid. All that kissy kissy will do is bring the two things closer together because they're in love. And so remember, that would be just written as a squared and b cubed. This is fabulous, Mr. Smith. This is very exciting. So having now got the rule where we are timesing floaty numbers, can we do it the other way? Can we divide floaty numbers? Well, this requires a bit of a hop, skip and a jump from you guys. Now you know this work, but you just need to watch what I'm about to do. Now let's go back to numbers first, because beforehand we did some numbers, all right? So, what do we do? Let's go, what's 5 divided by 5? Well, I've got 5 sweets and I'm sharing it with 5 people, and so we all get 1. Brilliant. What is 10 divided by 10? That's 1. What's 17 divided by 17? Also 1. Now, if you remember, anything that's divided by itself is always 1, right? That is a key rule. Does it work with letters? Well, it must do, because remember, anything divided by itself must be 1. So let me think. Does that mean that A divided by A is 1? Well, it must be. A divided by A is 1. So what about X divided by X? Also 1. Ooh, this is very exciting, right? Now, when we divide, what we're really doing is we're saying, well, if I've got an X on the top of a division sign and an X on the bottom, I can really replace them with the number 1. Now, there will be other maths teachers out there who will just be dropping in dread at the moment, but just stick with me, all right? What would happen if I had a squared divided by a squared? Well, the question is, are they the same? Well, absolutely they're the same, because a square apple divided by a square apple, these terms, this thing here is called a term, right? The bottom and the top are exactly the same, and when you take something and divide it by itself, you get 1. But we know that a squared is the same as a times a. So I'm going to rewrite it as a times a. And jumping back to fractions, I know that if all the tops are multiplied by each other and all the bottoms are multiplied by each other, I can write this up in a different way. I can actually write that as a divided by a times a divided by a. Well, we know a divided by a is the same as 1, and we know that a divided by a is equal to 1, and we have 1 times 1 is equal to 1, and life is fabulous. All right? What does this all have to do with the price of fish? Well, what happens if I have a cubed divided by a squared? Well, let's write it out longhand. So we know that a cubed is the same as a times a times a, and we know that a squared is the same as a times a. Oh, that looks complicated, but is it? So listen to what I'm about to say. When you do these type of questions, ask yourself, are all the tops connected by kisses? Yep, all the tops are connected by kisses. Are all the bottoms connected by kisses? Absolutely. So now I can use the rule that a letter divided by itself, or a number divided by itself, is equal to 1. So let's just check. There's an A on the top and an A on the bottom. That becomes equal to 1. An A on the top and A on the bottom, that becomes equal to 1 as well. So what do I now get left? Well, I've got 1 times 1 times A on the top. Well, 1 times 1 is 1, and times that by A must just give me A on the top. And what have I got on the bottom? Well, that's a bit weird. I've deleted them. I seem to have got rid of them, so I've got nothing on the bottom. Well, actually, yes, I have. Because remember that A divided by A means that I can replace them with 1s. So I've got 1 times 1 on the bottom, and there we go. But we know that anything divided by 1 is equal to itself. So A divided by 1 is the same as A, and so we have A cubed divided by A squared is just A. And I'm going to put a little floaty 1 here, because perhaps some of the observant people are already trying to find where I'm going to. Now remember, just as a recap, if we go back to the previous slide, what did we notice? When we multiply in the middle, when we multiply here, what did I do to the powers? All right, what did I do to the powers? I added them. When I multiply, I add the powers. Is that hint enough? Let's go back. So let's try a different example. Let's do a to the power of 5 divided by a squared. Well, we'll write that out longhand. A times A times A times A times A. There's 5 A's on the top, divided by A times A on the bottom. And ask yourself the question, are all the tops multiplied? Yes. Are all the bottoms multiplied? Yes. So I'm going to use the idea that I can now cancel, or the A divided by A becomes 1 divided by 1. So 1A and 1A on the top. They cancel. I've got an A on the top, cancels with an A on the bottom, and I'll replace them with 1s. Well, there's nothing else left on the bottom that I can cancel, so let me see. What do I have? I have 1 times 1, which is 1, and A times A, which I now know is A cubed. And what do I have on the bottom? 1 times 1, which is 1. Or what does that now equal? A cubed. So I now have that a to the power of floaty 5 divided by a squared is a cubed. Have you noticed the rule yet? Well, hopefully you have. So basically, for those of you who've got it, when you divide floaty numbers, you take the powers away. Now that would sort of make sense, because when I multiply, so a to the 6 times a to the 4, when I multiply, I add the powers, remember? So that become a to the 10. So it probably would make sense that if I was to do a to the 6 divided by a to the 4, then when I do the opposite to times, I must do the opposite to plus, and that means take the floaty numbers away. So in that case, that becomes a with a floaty 2. This is really cool. All right, so a couple more examples. A to the floaty 10 divided by a to the floaty 4. Well, are these the same? Yes, they are. They're divided, which tells me in this situation to take away the floaty numbers, and that becomes a to the floaty 6. These are two really awesome rules that we use in maths all the time, and so let's just remember them and we'll go on and practice them later. Okay, does this work with numbers? Well, of course it works with numbers. If it works with letters, it definitely works with numbers. So if I have 2 to the floaty 8 divided by 2 to the floaty 4, are the big numbers the same? Yes, they are divided, and I've just remembered that divide means I take them away. Now the funny thing is, look at the divide sign. That middle thing there almost looks like a minus sign. It tells you what you've got to do. So I'm going to write the same big number because the big numbers stay the same, but in this case 8 take away 4 is 4. And if I wanted to, it might ask me to evaluate that. Then I would just do 2 times 2 times 2 times 2. Remember, that is 4. Then times it by 2 is 8, times it by 2 again is 16, and lo and behold, my answer for 2 to the floaty 8 divided by 2 to the floaty 4 is 16. Oh, right, I can do another one. 3 to the floaty 9 divided by 2 to the floaty 3 must be, can't be done. Why can't it be done? Because this number here and this number here are not the same, so that can't be done. The only way I could write that any differently would be to change the divide sign so that it looks like that. There's no other way I could do that without using my calculator to solve it, because I do not know what 3 times 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 3 is in my head. Okay, very complicated. So this is the floaty number stuff. Shall we do a couple of more complicated questions? Shall I try and throw you and confuse you? Let's go on to the next screen. Okay, I'm going to do a squared b cubed divided by ab squared. Now you guys are probably already looking at this going, no, that looks too hard, that's too hard, I can't do this, it's too hard, I can't do it. Well, of course you can do it. Write it out longhand, okay? That's going to make life easier. So let's look at this first part here. Let's look at the a squared and b cubed. We know that's the same as a times b times b times b. Yep. Marvellous. And then this section, this AB squared, is the same as A, kissy, kissy, B, kissy, kissy, B, I would hope. Right, so let's just check. 2 A's and 3 B's on the top, all kissing together, yep. And 1 A and 2 B's on the bottom, all kissing together. Do we now have things on the top and the bottom that are the same? Well, absolutely. So we can use the rule that if there is a letter on the top and the bottom and they're connected by times's, I can replace them with ones. And a letter on the top, oh, no, hold on a moment. Hold the phone, we can't do that. So we're going to go backwards. We've got a B on the top and a B on the bottom. That becomes ones, and a B on the top and a B on the bottom becomes ones, and that's it. So let me think. We've got 1 times A, which is A, times 1 is A, times 1 is A, times B. So that becomes AB. All over 1 times 1 times 1 is 1. And we know that anything divided by 1 is the same thing. And there we go. So I know that A squared BQ divided by AB squared is just AB. Really big hint here is write it out longhand and then use the idea of cancelling. But I just want to make sure that you remember something here. If I had an example where I had A times A plus B times B times B divided by A times B times B, this cannot currently be cancelled down. I can't use my cancelling rule. You're sitting there probably wondering, well, why can't I? Well, remember, you have to say that it doesn't work because that plus makes things not work, all right? The cancelling only at the moment works when all the top are timesing and all the bottom are timesing. Now, what is maths? I hear you're screaming in the background saying, hold on a moment, it's hashtag BFT, all right? Hashtag big fat trick. So let's just see whether we can come up with something. Let's go back to this A divided by A business, shall we? Well, we've already decided that if I have A divided by A, that must be equal to 1, because you divide anything by itself, it's equal to 1, yes? Well, we now know as well that when we do our dividing of floaty numbers, we take them away. So let's think, there's a 1 and there's a 1. Are these things the same? Yep, so there's my A. I'm dividing, so I do 1, take away 1, which gives me 0. Ooh, funky. So bearing in mind this A divided by A here is exactly the same as this, then it must mean that this answer here is exactly the same as this. So we can now say, well, hold on then, that A to the floaty 0 must equal 1. Well, what about B divided by B? Well, we know that B divided by B is 1. And we've got a floaty 1 here and a floaty 1 here. We know now that B, 1 take away 1 is 0. So that must mean from here that B to the floaty 0 is also 1. That's a bit tricky. Let's try it with something else. Let's have, oh, I don't know, x squared divided by x squared. Well, we know that x squared divided by x squared, anything divided by itself is 1. And we know that their bases are the same. We can take away these numbers here. So 2 take away 2 is 0. And once again, x to the floaty 0 is equal to 1. And here, ladies and gentlemen, is the big fat trick. It is the life, it is the thing you need to know. It's the one thing that is the biggest trick of all the floaty numbers. And it is this. Let's watch. X to the floaty 0, 1. A to the floaty 0, 1. B to the floaty 0, 1. If I told you that 2 to the floaty 0 was 1, and 10 to the floaty 0 is 1, and 100 to the floaty 0 is 1, and A, B, C in brackets all to the floaty 0 is 1, there is a trick. Anything to the floaty 0 is always equal to 1. Hurrah! Big trick. Remember. So let's see if we can come up with some really complicated questions. Okay, I'm going to take some of the questions from the textbook just see what we come up with. So let's see, we've got m to the floaty 3 times m to the floaty 4. Remember, ask yourself the question, are the numbers the same? Yep. Are they floating? Yes. So there we go. M is my first thing I'm going to write. Now we're timesing, so what do we do to my powers? Did I hear you say add them? I certainly did. 3 plus 4 is 7. Right answer. Ooh, next question, that was even vaguely difficult. K times k to the floaty 5. Have you already got the answer? Hopefully. Okay, so let's think. Are the letters the same? Yep. Is there floaties? Yep. Ooh, let's put a little 1 in here. There was a trick. All right, so now add them, floaty 6. Job done. We are geniuses at this. Okay, let's make it harder. Right. M to the floaty 4 times m to the floaty 3 times m to the floaty 2 times m to the floaty 10. This isn't difficult. Let me ask you, does it matter that there's more than one? No. Are they all times together? Absolutely. Are the letters all the same? Absolutely. So there's my m. What do we do to all the powers? We add them. So we've got 4, 5, 6, 7, 8, 9, 10, and that's m to the 20. Guys, this stuff is amazing. Let's throw some numbers in now. 4m squared times 5m to the 3. Ooh. Now this is just going to require you to remember what is between the 4 and the m squared. Well, it's a kissy. In this situation here, the floaty 2 belongs only to the m, not the 4 to the m. So that's the same as 4 times m squared. There's a times here, must write that in. And we know that 5m cubed is the same as 5 times m cubed. Well, what is that going to do to help us? Well, let's go back and just remember, when we have everything times together, it's awesome, because we know that 1 times 2 times 3 is 6, and 3 times 2 times 1 is 6, and 1 times 3 times 2 is 6. Well, I'm a bit bored now, so we can move on. But basically speaking, when things are times together, we can move the order around to make it easier for us. So I'm going to put all my numbers first. 4 times 5 times m squared times m cubed. Well, I can do this now, because remember, where you can in maths, you simplify. Do I know what 4 times 5 is? Of course I do. It's 20. Copy that times down, and there we go. I've got an m floaty number times an m floaty number. Well, the m's are the same. There we go. And we know because we're timesing, that becomes 2 plus 3, which is 5. And the kissy rejoins them back together. And so what do we have? 20m to the floaty 5. Right? You can do this stuff. And even if we had a negative number, maybe I had minus 7x squared y cubed times 2x5y. Guys, it doesn't matter. Let's think. We know between any number and letter there is a kissy. So that's the same as minus 7 kissy x squared kissy y cubed. Copying down that times, don't forget it. There's a 2 kissy x to the 5 kissy y. Well, because they're all kissing together, we can move them around and make things easier. So let's move my numbers to the front. Well, we've got minus 7 times 2. So that's that done and that done. Let's deal with my letters in alphabetical order. So I've got an x squared and I've got an x to the 5. So times x to the 5. I've got a y cubed times y cubed and times y. Did you notice there that I actually crossed things off when I'd used them? That's so I don't forget anything. Well, remember, in maths where we can, we simplify. We know what minus 7 times 2 is, don't we? Because we know that 7 times 2 is 14, and a minus and a plus becomes a minus. We've got a kissy here, which I can't forget, so there's my kissy. I've got an x squared times an x to the floaty 5. Well, the x's are the same. There's a time, so I'm going to add. And then we've got a kissy there. Don't forget this one here. We've got y cubed times y, which is y to the floaty 4. And so the kisses can now be written by joining everything back together again. And voila. This is amazing. Last page, I promise, before the end of this video. Let's just do a couple of questions where we do some dividing. Okay, so here we go. What about m to the floaty 5 divided m to the floaty 2? Well, you can do this in one of two ways. You can either write it out as m times m times m times m times m all over m times m. Ask yourself the question, are they all kissing on the top? Yep. Are they all kissing on the bottom? Yep. So I can now say, well, one of those m's can cancel with one of those m's. Let's put one in its place. And an m on the top cancels with an m on the bottom. And so what does that leave me with? M with a floaty 3 on the top, because 1 times 1 is 1. M times m is m cubed, divided by 1 times 1, which is 1. And anything divided by 1 is itself. That's one way of doing it. Or I could have just done m to the floaty 5 divided by m to the floaty 2. Are these the same? Yep. There's my m. Floaty numbers, yep. A divide in the middle says take them away. And so 5 take away 2 is in fact 3. There are harder questions here though, aren't there? Absolutely. Now there's only so much I can teach you in a video, and I'd love to sit here all night just talking to myself, but here's my last example. I wonder if you can work out how I got the answer. M to the floaty 5, n to the floaty 7, divided by m to the floaty 3, n to the floaty 2. Let me think. Well, we could write this longhand. So I've got m times m times m times m times m. So there's my 5 m's times n times n times n times n times n times n times n. 1, 2, 3, 4, 5, 6, 7. Perfect. So let's draw my divider line. Not very straight. Never mind. M cubed is m times m times m times n times n. Now this is where we have to be very, very careful, because it becomes really easy to actually miss things. So let me find the top. So are they all times on the top? Yep. Are they all times on the bottom? Yep. So if there's an m on the top, it goes with the m on the bottom. M on the top? Yep, goes with the m on the bottom. M on the top? Yep, goes with the m on the bottom. Any more m's on the bottom? No. So I can't cancel this m with this n. But I do have an n here that cancels there, and an n here which cancels there. And so let's see what we've got left. Well, I've got an m times an m, which is m with a floaty 2. And I've got 1, 2, 3, 4, 5 n's there. Must be n with a floaty 5. And what have I got on the bottom? Well, remembering these are all really 1s. That's 1 times 1 times 1 times 1 times 1, which is 1. And so I get m squared over n to the 5. I wonder whether there was a quicker way to do this. Well, I think there is. Let's just look. M to the 5, n to the 7, divided by m to the 3, n squared. Well, I've got 5 m's on the top, and I've got 3 m's on the bottom. What did I notice? I had 5 m's on the top and 3 m's on the bottom. But 3 of the m's disappeared. They went, didn't they? Because they went off the bottom. So 5 on the top and 3 on the bottom meant there were 2 m's left, because I did 5 take away the 3. Well, let's look at my n's. I had 7 on the top and 2 on the bottom. When I cancelled the 2 on the bottom, what did I have left? 5 n's. So 7 take away 2 gave me n to the floaty 5. My goodness, Mr. Smith, this is jolly good. Last couple of examples. 4k to the floaty 10 divided by k to the floaty 7. Well, this number here is just a number, so at the moment I'm going to leave that with a 4. I've got 10k's on the top and 7k's on the bottom. Well, if I was to write it all out longhand, then 7 of those k's would cancel out and would leave me 3 left. So 4k to the floaty 3. This is easy. One more example. 30, x to the floaty 20, y to the floaty 12, divided by 5, x to the floaty 2, y to the floaty 5. Now, are all the tops times together? Yes, they are, remember? And the same is true here. Between that 4 and the k is a kissy-kissy. Between the 30 and the x is a kissy-kissy. Between the x and the y is a kissy-kissy. The same here. So because they're all kissing on the top and all kissing on the bottom, I can say to myself, well, okay, I've got a 30 on the top, and that's the same as 30 divided by 5. Well, I know that 5 goes into 30, so 5's go into there once, 5's go into there 6 times. I've got 20 x's on the top and 2 x's on the bottom. So those 2 x's are going to cancel 2 of those to leave me just 18 x's left. And I've got 5 y's on the bottom and 12 y's on the top. 5 of those y's will take off of there and give me 7 left. And so, what do I have left? I've got 6 times x to the floaty 18 times y to the floaty 7 all over 1 times 1 times 1, which is 1, or 6 x to the floaty 18 y to the floaty 7. That was a lot of information in this video, but now you are totally able to answer all of the questions in exercise 5J, right, page 308. Now I'm doing this video to try and help you do even better in your even better in your post-test, right? So fingers crossed, you can sit here and pause it and play it and rewind it and do it all again and come and ask me questions. That's what I'm here for, right? I want you to do freaking awesome in this exam, and just remember that maths is a big fat trick. Hold on, I can hear you say, "Hello sir, Mr. Smith, please give me one more." All right, here we go, last thing then. So let's do 3x, and we'll do that with a floaty 2 above, but in brackets. Now, what does the brackets mean? The brackets tell you to keep things together, right? So they have to stay together. And in this situation, that little floaty 2 tells you, well, a floaty 2 tells you to write it twice. So what this is telling you is write what's inside the bracket twice. That's the same as 3x times 3x. We know that now. So look, that's what the floaty 2 said. What's inside the bracket, write it twice. Well, I know that's the same as 3 kissy x times 3 kissy x. And I can write that again in a different order. Let's put all my numbers together because they're all timesing together. And so 3 times 3 is 9. X times x is x. Well, there's a floaty 1, there's a floaty 1. Add them together, x squared. Don't forget this little kissy in between. And that means that we can now simplify that to 9x squared. Should we throw in a trick? Absolutely. Let's have 3a squared b in brackets to the floaty 0. Wonder what that means. Hold on! Alert! Trick! Big fat trick alert! Alert? Alert. What do we know anything to a floaty 0 is? Abso-positive-alutely. Anything to the floaty 0 is 1. Big fat trick. Anything to the floaty 0 is 1. But if I had 3a squared b all to the floaty 2, for example, well, the floaty 2 tells me write everything in the bracket twice. 3a squared b times 3a squared b. We know there are kisses between all of those, so that's 3 kissy a squared, kissy b, kissy 3, kissy a squared, kissy b. And so let's move that all around because we know we can because it's all kissing between. So 3 kissy 3, let's put the numbers together. Then a squared kissy a squared times b kissy b. And in maths, remember what we need to do when we can is we simplify. 3 times 3 I know is 9. Copy down the kissy here. A squared times a squared, well, we add the powers. Copy the kissy down. And b times b is b squared. And so, can I make it any simpler? Nope, I can't add the powers here because the base things are the same. So that becomes 9, a to the 4, b to the squared. Ladies and gentlemen, I've spoken for too long. I'm enjoying this too much. I'm going to call it a night, all right? Maybe I'll do another video soon, but up until now, good luck with the post-test. I believe in you.